Hello. Now we talk about edge deployments. Now, typically, when you start building a model and start thinking about it in a more conventional perspective, you always think about models residing somewhere on the server, right? And the server is typically on some sort of a cloud like Azure, Google Cloud, or AWS, or wherever it is, right? But I mean that definitely was the case a couple of years back, but in last couple of years there have been a lot of focus on moving the models uh, closer to edge as possible, and this is really coming from many of the industrial use cases. For example, if you are building a machine learning model uh, that for example detects the faces that are present in your uh, mobile phone pictures, and then it organizes uh, your pictures on the basis of certain people, right? Now, where does this model reside? Now, there are many ways. You could, for example, reside this model on the cloud, in which case the data in the data somehow from your phone is sent to the cloud, and there it is analyzed by your model and then grouped together. So that is one way. The other way is if you're using something like an iCloud or Google account for your Android or iPhone, then all of your photos are by default stored on the cloud, and it becomes very easy for performing those kind of computations. But then there are certain other use cases wherein the model needs to reside on device. For example, if you are speaking to your voice assistant like Siri or Hello Google, if those models are present on the device, then the performance is going to be much faster, and it also has a great privacy impact, because you don't need to send the voice of the user and any other ambient voices that are present along with that user all the way from that user's home to the cloud, right? You are able to process all these things on the device, and that is a great privacy focused approach to build machine learning models and deploy them. And that same goes for a lot of devices. A lot of devices are actually trying to push models more and more on the edge, as close to the data generation source as possible, so that the compute resources are also consumed from the user's device rather than the server. And there is a great privacy aspect also, plus the whole latency, it just increases a lot. And these are really the main reasons why people would want machine learning models to be as close to their data sources as possible. And this is especially true in industrial scenario as well. There are many factories which are not very keen on sending some parts of their data in the cloud. They are storing those data locally, their premises, and they would want the machine learning models to be working there as well. It also comes because in certain industrial scenarios, the frequency of data is very high. You could have data coming in from maybe 10-12,000 sensors at 2 to 5 millisecond granularity, and you would need to be able to process this data and be able to for example predict what is going to happen in the future, or detect some anomaly within those time ranges itself. So these kind of situations make it make it very obvious that the model cannot reside away from the data source. It has to reside as close to the data source as possible. And a self-driving car is a great example, right? It has all the characteristics of a consumer application, and also from an industrial application, in terms of the the responsibilities that a machine learning model holds, that is guiding your self-driving engine is a lot. And that's where edge deployments really make their mark. Now, how do you really deploy your models on the edge? And this is very simple. Like you have to really follow all the processes that you do for creating your machine learning models, right? So you start with your Jupyter notebook, you connect to your data sources in S3 or wherever you start training and testing your model. And once this model has been given a green signal by the data science team, then it becomes valid enough for it to be deployed. Now, if you want to deploy this model to iOS, right? So iOS has a framework called as Core ML, which is the machine learning framework that Apple provides support for. And it also provides a Python package called Core ML Tools that helps you convert a model written in, for example, TensorFlow or PyTorch into a Core ML format, and these Core ML models can then be used by your iOS application to perform on-device inference of any data. Similarly, when it comes to Android, there's TensorFlow Lite and there's PyTorch, and these models can be natively used by an Android application. There's also MLKit, which is an on-device machine learning from Google. It's a framework and it's cross-platform, so you can use MLKit for your iOS and Android applications both. And it comes with a bunch of preloaded models, and then you can of course define your own model and perform training and testing on them. Now, the top considerations for mobile devices and machine learning models on edge are really around energy, resources, real timeliness, and connectivity, because these four things are always in sort of a crunch mode, right? So your machine learning model needs to be designed with these considerations in mind. It should use the minimum energy, resources. It needs to be as real time as possible, and of course the entire system needs to be more resilient to loss of internet connectivity if it expects something from the internet. Now, when you are actually deploying these models, one of the crucial thing to keep in mind is, because your application might remain the same, but your models might change much faster than your application, right? So in those cases, what happens is, typically if you bundle your machine learning model with the, let's say, iOS application, and every time you update the model you have to ship a new version to the customers, and it might be annoying for them to simply update it, or worse, you could have situation wherein certain users are working with a different version of model while certain others are working with a totally different version of the model altogether, right? So in order to avoid these kind of inconsistencies, what it is generally recommended is that you have some sort of a model server, and what this means is that you don't ship your iOS or Android application with the machine learning model. Rather, this app downloads the model on the first launch, or when the need arises. So when the users first start the model, you check for if there is an updated version of the model, you download that model, and then you start using it, right? And this can be a very seamless way to ship out new models to the users without asking them to update their applications. Yes, I think that's pretty much all in mobile devices. Like I said, it's very similar to what you already do. You just need to package it differently, and maybe depending on your production use cases, you might want to use a model server instead of shipping your models directly on the application itself.